Question number 51. Which of the following molecules contains equal number of sigma and pi bonds? We have different compounds given here and we need to just find out their shapes. So first is XiO2F2. I'm just drawing here the shape of this XiO2F2. This, and now you can clearly observe the number of bonds present here, sigma bond and pi bond. Before that, let's draw for this POCl3 also. This POCl3 is this type of species. Further, we have CO, this molecule, and SO3. SO3 is this type of molecule. Now you can clearly see that in first molecule XiO2F2 there are 2 pi bonds and rest sigma bonds. 4 sigma bonds are there. It means it does not contain equal number of sigma and pi bonds. Further, in this case also 1 pi bond is there and 4 sigma bonds are present in case of POCl3. Further, in case of CO there are 2 sigma bond and 1 pi bond. In case of SO3 there are 3 sigma bond and 3 pi bond. It means this is that molecule in which equal number of sigma and pi bonds are present. And if you know this, you can easily choose option 4 as the correct one. Question number 52. A certain gas takes 5 times as long to effuse out as H2 gas under identical conditions. Its molecular mass will be. In this case, we have a certain gas, say that gas is X. For this particular gas X, the rate of effusion is suppose Rx. We know that rate of effusion is equal to the mass of the gas effused per unit time. So we can say that this Rx is inversely proportional to time taken by the gas during the process of effusion. Similarly, if we apply Graham's law of diffusion, we can also apply Graham's law of diffusion for the process of effusion, and we know that this R is, talking about that particular gas, inversely proportional to molar mass of that gas. These two formula we have. It means we can relate R value with time taken by gas for the process of effusion as well as the molecular mass of that gas. Now, if we talk about this gas Rx and hydrogen, if we compare them with the help of their molecular masses, we can represent this as molecular mass of hydrogen and unknown molar mass of that gas. Further, this Rx by RH2, this is equation 1, and the second equation Rx by RH2 is equal to TH2 by TX. These two things we have here, those we are just going to compare. These two equations basically. We know that time taken by hydrogen is suppose T, then definitely the time taken by that unknown gas is 5 times of this. This way, these T can be cut, and ultimately we are getting here this mx that is equal to 5 square into 2, that is 25 into 2, and it's equal to 50 gram per mole. That would be the molar mass, and definitely the molecular mass would be 50U. So I'm just choosing 50U. That's given here in option 3 as the correct answer. After this, there's another question, that's question number 53. Which of the following reactions enthalpy correctly represents standard enthalpy of formation? If we talk about standard enthalpy of formation, this is basically the term which is used for the process in which 1 mole of the substance is formed from the substances which were present in their standard state. If we talk about the first option, H2 plus Br2 to give you 2HBr. One thing, there are 2 mole of this HBr are formed. It means for this reaction, enthalpy of formation is not equal to reaction enthalpy. Further, bromine is also taken here in the form of gaseous state, but the standard state of bromine is liquid. So, this is not representing the correct answer. For the second option, carbon is there in the form of diamond combining with oxygen to form CO2. Yes, 1 mole of CO2 is formed, But carbon is not here in its standard state. It is in the form of diamond, but it should be graphite if we want to find out the standard enthalpy of formation with the help of the enthalpy of this reaction. This is also not the correct answer. Further, H2 plus I2 giving you 2HI. In this case, iodine is there, that's in liquid state, as well as 2 mole of HI are formed. This is also not representing the correct value of standard enthalpy of formation. Further, 1/8 S8 rhombic sulfur we are taking, hydrogen gas is there and SO2 is formed. 1 mole of SO2 is formed here. It means in this case, the formation enthalpy of this 1 mole of SO2 is representing the standard enthalpy of formation. Why? Because we have taken here S8, rhombic sulfur we have taken here, and that is the standard state of the sulfur, and ultimately it combines with oxygen, that's also in the standard state, and 1 mole of this SO2 is formed here. That's why option 4 is the correct option. And after this, question number 54. The equilibrium constant Kc for the following reaction will be. We have this given reaction here, and with the help of this we need to just find out equilibrium constant. What's that? That's Kc. And by looking at this reaction we will identify that this is heterogeneous equilibrium, and in case of heterogeneous equilibrium, the concentration of pure solid or the pure liquid is assumed to be unity. So in this case, if we just want to find out this Kc, value for this Kc should be calculated with the help of the active mass of chloride ion, which are given in this reaction at the product side, and the sulfate ions. While PbSO4 is there in the form of solid and PbCl2 is also in the form of solid, and these two are in their pure form, and that's why their active mass is assumed to be unity or 1. And on that basis, the Kc value for this becomes this. And where this is given here in option 3. That's why our answer for this question is option 3. After this, question number 55. Question number 55. The compound which is not stable at room temperature. We need to just check the options given here. If we talk about the first compound, this form has 4n plus 2 pi electrons. Aromatic. Why aromatic? Because it contains 4n plus 2 pi electron, as well as it is planar molecule. That's why it is aromatic, and on the basis of this, it is stable at room temperature. For the second option, we have the compound given in the second option has 4 double bonds given here, and it is a non-aromatic compound because it is not following the principle of aromaticity. That one, it should be planar, it should have 4n plus 2 pi electron. That's why it is non-aromatic. Now the compound here is in option 3. If we talk about this compound, it is also non-aromatic. And the compound here given in option 4 is anti-aromatic. Why anti-aromatic? Because in this case, it contains 4n pi electrons, where the value of n is 1, 2, 3. So this case, it contains 4n pi electrons, and this is anti-aromatic. And we know that anti-aromatic compounds are not stable at room temperature. That's why this option 4 is the correct option for this particular question.